Hello students, today we are going to understand some of the chemical equations student from the haloalkane and haloarenes. So let's try to have a look over it, that whether we are able to understand some of the problem or not, right? So those who are online, thank you very much for being live. And students, let us see the first equation. Student, I have taken from the this all the equation from the haloalkane and haloarenes. Here is student, alcohol is there. This is what the alcohol, right? Alcohol are polar in nature and you are treating with the HCl student. So they are asking that is what the product you are going to expect here student. So what is happening student, here the hydrogen and OH is going to be combined student and it is going to give water student, and here what is that is haloalkane is going to be formed. Okay, so this is what the answer is student. Now the second one is here student. If you talk second one, so how the reaction takes place student, if I will split this H2SO4, so here we can write HHSO4 student. This way we can write student. Here if you see, this OH and H can combine, right? So here what is the one compound is the for sure that is H2O. Second compound you see student, this sodium is there, right, and HSO4. So this is going to form. So it is what is student, NaHSO4, sodium hydrogen sulfate. And what is left student, here you see the bromine is left and here is R. So again it is also a method of preparation of the haloalkane student. So bromoalkane is going to prepare. Now PCl3, okay, PCl3 trihalide you are using student. So whenever PCl3 is there student, you are going to take the 3 molecule of the water alcohol. So what the going to takes place here student. So let's see, the only 2 products are going to form student. Here is 3R student, it is reacting, and here is the 3Cl is there. So here it is going to form student 3RCl. And secondly, what is left student, 3H is there student. So 3H it is written like that H3, 1P is there, so P, and 3O is there, H3PO3. So this is what the H3PO3. So again it is method for preparation of the haloalkane. Now if you are taking the PCl5 student, so first compound is RCl, then another is the HCl, and last one is POCl3. So you will calculate this one. If you balance this one, it is obviously balanced one student. Here is their alcohol you are treating with the red phosphorus and halogen student. So it is already going to give the RX student, because here X is you used. If it is the equation is like that ROH, and you are using the red phosphorus student, and what is that is Cl2. So what it is going to give student, this is going to give the RCl. Okay, this the product will be there student. Now this is the ROH and thionyl chloride student. This is called Darjan process. This is the Darjan process. So how you prepare with the Darjan process student? So it is the best process for the preparation of haloalkane, because the 2 side product whatever form student, they are the volatile gaseous product, they escaped and liquid is formed student. This is, so this is the best method for preparation of haloalkane. Here you see the equation number 7. It is again treating with the HCl student. Here the ZnCl2 is required student. So what will happening student, this water is going to be out student. So here is the chloroethane is the going to form CH3, CH2 and Cl. Next one is what is there student, here is the H2O. Similarly here is the ethanol is there, NaBr and H2SO4. So dear student, what it is going to be CH3, CH2, and here is the Br student, plus here will be H2O, and finally NaHSO4 student. This is sodium hydrogen sulfate. Now ethanol is there and thionyl chloride is there student. Here is CH3, this is CH2, and here is Cl student, and then SO2 will be formed and Cl2. This is the Darjan process. PCl5 student, always you try to keep in mind the what is the side product, student. Here the side products are important. So CH3 CH2 Cl plus it is the H2O, student. What other things it is there, student? Other things, it will be POCl3, student. This is. Now let us try to understand one more, student, this reaction. So this is the 11 number. What is there, student? Here is Cl2 and UV light is there na. This gives the free radical substitution reaction, student. Free radical substitution means you are substituting the hydrogen with the help of chlorine. So two products are possible, student. Either you can replace this hydrogen, student, or you can replace this hydrogen. Both hydrogens can be replaced. So here the many isomers form, student. So first product is there, student, CH3 CH2 CH2, and here is again CH2 Cl plus side product is HCl, is obviously HCl will be there. This is the minor, student, because it is after ionization it will give 1 degree carbocation. So it is the less stable compared to this one. CH3 CH2, student, again CH, here it can be Cl, then CH3. Okay, this is the 2 degree now. So this is quite more stable, right? So this is, and side product is what is, student? HCl. In both the cases side product is HCl. Now move on the next problem, student. Here suppose, student, if you are seeing the question number 12, here you see this is the ring, student. Here it gives the addition reaction, but here the UV light is there now, so they cannot give the addition reaction. UV light there means free radical substitution reaction, student. So in this case, what the product we are expecting here, friend? The product will be what is the benzyl chloride, student. Here is the benzyl chloride, CH2Cl. Okay, next one, student. Here you see, student, dark is there. Dark means the addition reaction, student. Means electrophilic substitution reaction it will give. So here is FeCl3 is there, catalyst there. So it will give the electrophilic substitution reaction, and two product are possible, student. So here CH3 will be as it is, student. Here it will be that is Cl. Okay, Cl means here nothing they have given, so you can also write the X, student. It can be here it can be X. Next one, what can be there, student? If you talk about the another one, so here is this is the CH3. Here this position, ortho position. So this is what the student, that is going to be minor, and here this is going to be what, student? Major product, right? So these are the. Now let us move out the next one, student. Question number 14. It is quite important. So here is this compound is called aniline, student. Aniline, and here is NaNO2 and plus HX, student. This is called diazotization process, student. Diazotization. Diazotization means diazonium chloride will form, student, right? Because this is the diazotization reagent. So what the compound you are going to receive here, student? This compound is going to give N2Cl. This is the N2Cl. Cl is negative and this is positive. Friend, here if you are treating with Cu2 Cl2, so here it will come that is Cl. Okay, so this compound is the what? Diazonium chloride. You can see, student. Benzene ring is having N2Cl. Now the same reaction, almost similar reaction they have given here. The first step will be same, student. This is the diazotization reagent. So here the A will be what, student? Here it will come N2Cl, friend. N2Cl. This is minus, this is plus. Now Ki. So directly it is going to be replaced, right? So B will be what? Here B will come, student. That is here it will be the I plus it will give the N2, and KCl will be out, student. So this is what the iodobenzene will be formed. Now let us move on the question number 6 here, 16. Student, here the three product we have to form. Here is the nitrobenzene. This compound is called, student, that is called nitrobenzene, right? And this nitrobenzene, if you are treating with the hydrogenating catalyst, this is what, student? This is the hydrogenating catalyst. Hydrogenating. Why hydrogenating catalyst? Because metal hydrogen is there and metal catalyst is there. Hydrogenating catalyst. Okay, so it easily reduce the NO2 group into aniline, student. So what will be the A, student? This A will be called the NO2. Now here is the diazotization, means Sandmeyer reaction, student. So what will be the B student? That will convert into the aniline, right? NH2 student, sorry, this is the NH2, na, NO2 already there, sorry. So friend, it is the NH2, NH2, and here it will give student N2Cl, right, N2Cl. Now Cu2Cl2 if you are treating a student, so diazonium chloride will convert into what student? Chlorobenzene. So this is what the very simple student, this is what we are receiving, chlorobenzene. Now let us move student and try to solve the one more problem. What is the question number 17? If you see the question number 17 student, so what is there? The similar half reaction is the same one student. What is there? It is the Sn plus HCl, metal acid student. When metal react with acid, it always give what student? Hydrogen gas, right? It is the Sn plus HCl, metal. So if it is giving the acid, friend, if it is giving the acid, so what it is going to happen here, right? This NO2 will be reduced to NH2. So here you see, this compound is going to give NH2, right? Now this is the diazotization reagent, means Sandmeyer reaction. So it will give what student? N2Cl. This is what? N2Cl, negative and positive. Now this one Cu plus HCl, this is called Gattermann reaction student, Gattermann reaction, Gattermann reaction, and this Gattermann reaction will result in the preparation of chlorobenzene. So here it will be the Cl student. So this is also a method to prepare the chlorobenzene. Now let us move out the question number 18 student. What the question number 18 you can expect here, friend? If we will see question number 18, so 3 reaction all together they have given student, 3 reaction all together. So let me check here student, little bit go the below, sorry, yeah. So here you see the N2Cl student. So Cu2Cl2 in presence of HCl student. So what it is going to give student? Okay. So here if you see, so this is also all are the example of what student? They are the example of Sandmeyer reaction. Sandmeyer reaction. Okay, where the this chlorine going to be halogen is going to be substitute. So here it will be, that is what student? Cl plus N2 will be out. Okay. In case of this one HBr student, it will be here its student, it is Br plus N2, and last one here it will be the Cn student. Okay. So benzene nitrile it will form student, and plus N2. So this is also going to be very simple reaction student, right? Now move on to question number 19 student and try to find out what are going to be the answer. Okay, this is the example of Gattermann reaction, Gattermann reaction student. So Gattermann reaction, so here is the, they are saying you need not to take the cuprous chloride and this all, just copper powder you are taking an HCl, hydrogen halide, it will give the substitution product student. So it is the plus and here is minus. So what the product here you are going to receive, friend? This will be the, here it will be the Cl, right, and here plus N2 will be as usual, and here is student, here will be the Br. So it is the more easier than the Sandmeyer reaction. Directly if you are treating the hydrogen halide with the copper powder, so it will give the product. Here you see student. Now this one, see Balch-Simon reaction, this is called student Balch-Simon reaction, Balchsimen, Balch-Simon reaction. In the Balch-Simon reaction, what is diazonium chloride is there student, and diazonium chloride is going to give fluoroboric acid. So what it is going to give student? It is going to give one complex student. Here is the HNCl will be out. So what the complex will be? N2BF4, right? Now student, in the last case what is happening? BF3 it is going to out, plus N2 is going to be out. So what is going to left here, friend? You can see this is the, here the fluorine is going to be appeared, student. So it is the fluorobenzene is going to be formed, right? So this is the best way to prepare the full fluorobenzene. Now let us move on to question number 21. What is there, student? This is the alkene are there and hydrogen halide are there. Here nothing they have given, student, so directly it will give the addition reaction, means hydrogen is going to be added here and halogen is going to be added here. So see, student, what going to be product? CH3 CH2 and it is the Cl, right, student? So this is what is the product, friend. Now let us move with the question number 22. Here, student, there is no peroxide and this is hydrogen halide. So it will give what, student? According to Marconi-Kopp's rule. It will go according to Marconi-Kopp's rule. And what will be the product, student? In case of Marconi-Kopp's rule, student, the rule say that is negative part, okay, negative part of the reagent, student, it goes to that double bonded carbon atom which have less number of hydrogen. So this is the positive and this is the negative, student. Now one thing we got to know, which is positive and which is negative, student. So we can now frame the questions. One second, student. Yeah. So students, let's see this one. So negative part is going to add on that double bonded carbon which have less number of hydrogen. So it is having only how many hydrogen? One hydrogen. And here if you see, two hydrogen are there. Here valency is filled, so here no addition not possible and hydrogen will go here. So that is 2-iodopropane is going to form. So let us write the product, student. Here is CH3, this is CH. Here is what, student? This is I and here is CH3. So if you are writing the product, friend, so 2-iodo, this is called iodo, 2-iodopropane. This is what our required answer, student. Now let us move on the next one, student. Question number 22. So here is, student, carbon tetrachloride is there and 2 bromine are there. So one bromine, no, with each carbon it will go. So dibromo alkane will be forming, student. Okay, so here is Br and this side is Br. So it is very simple, student. We are not wasting the time on it. Question number 24. Total 50 equations are there, student. Here you see, student, on this position 1 hydrogen atom, on this position 2 hydrogen atom. So what rule you are going to follow, student? Marconi-Kopp's rule. This is called Marconi-Kopp's rule. So according to Marconi-Kopp's rule, student, negative part is going to add on that double bonded carbon atom which have less number of hydrogen. So it is going to be, and this is here. So if you are writing the product, friend, so let me try to write the product here. This is, here is, student, C, H is as it is. Here is the one bromine atom is also going, student, and here is the carbon is there, right? One hydrogen, another hydrogen and another. So this is what is our required product, student. Now let us move on to question number 25, friend. This is again according to Marconi-Kopp's rule, student, because this is the unsymmetrical alkane, both side of double bond different groups are there. So what will happen? Negative part, this is the negative and this is part 3. So negative will go on that double bonded carbon which have less number of hydrogen, and this is like that. So here is the CH3, CH2, here is CH. This will be what, student? Here is the Cl and this is the CH3. So 2-chlorobutane will be the product, student, 2-chlorobutane, right? So this is what you can understand here. Okay, next one is peroxide is there, student. So this is what going to be anti-Marconi-Kopp's rule. This is what called, student, anti-Marconi-Kopp's rule. It will work according to anti, means negative part of reagent will go on that double bonded carbon atom which have more number of hydrogen. So friend, if I will ask you where the negative part is going to be, where the bromine is going to get added, student. So bromine is going to add on this position, student, because here the 2 hydrogen is there, here is 1 hydrogen. So this is going to be according to anti-Marconi-Kopp rule. So let us try to write the product, student. This is the benzene ring, here is the CH2, here again it is going to be CH2, here is what, student, CH2, and here is Br. So this is our required product, student. So up to 26 we done, student. Now here they have given, student, Finkelstein reaction, student, iodide exchange now. So NaCl will be out, student, and here is what will be there, friend, Ri plus it will be NaCl. Here is again, student, if you are talking about Ri plus NaBr, student, so same way they are, this is called Finkelstein reaction, Finkelstein, Finkelstein reaction, student. Okay, now if you are this is, student, Swart reaction, this is the fluoride exchange is called Swart reaction. So friend, how to sort a reaction? So AgBr will be out, student, and F will be, so here is CH3 and F plus AgBr will be as it is out, student. Next one, student, here is the alcohol. Sometimes student think this is the phenol, but it is not a phenol because here no alternate single and double bond. This is not the benzene ring, it is cyclohexanol, student. So cyclohexanol means this is the SO2 will be out, student, now SO2 plus HCl. So what will be there, student? Sorry, here we cannot put the now see, let us firstly rearrange, student. It is, so here will be there, student, this is the what, the cyclohexane, and this is the Cl group plus SO2 group will be out, and here is HCl also, student, HCl. So this is what the product. Now let us move on the next one, student. Here see, this is the phenolic group, student, it cannot be split, phenolic group cannot be split. Okay, so this is not going to give reaction, student. So Asa, put the headphone now, Asa. So here you see, student, this case here is the water will be out, student, and chlorine will be added here. So friend, if you write the product here, so you can easily write OH cannot react, student, because it is the partial double bond character in the phenolic group. Here will be the CH2 and Cl plus here water, right? So very simple, student. Now we are moving on the 32, student. Here see, sunlight is there, student. So it cannot do anything on the ring, student, because the ring is electrophilic substitution. Here there is no catalyst to form the electrophile. It is will give the free radical. Free radical is the property of the alkane. So where it is going to give, student, that is the two products are possible. The major product I am writing here is CH. This place will be the Cl, student. Here will be what, friend, this is CH3, and NO2 group will be as it is, NO2 will be as it is. So this is what the product, student, right? So now move on the next one, student. Here HI is there, student, 1 2 3 4, right? So this place 0 hydrogen, this place 1 2 3 1 hydrogen is there, friend. If here this is going to be a unsymmetrical alkene and hydrogen halide, so again it is going to follow which rule, student? Marconi-Kopp's rule. This is the following Marconi-Kopp's rule, friend. So according to Marconi-Kopp's rule, student, negative part of the reagent is going to attack on which position, student? Where the less number of hydrogen are there. So here is the 0 hydrogen, so it is going to add here and hydrogen will be here. So what is the going to be product, friend? See, this is not the OH group, student. This is, I wrote that is 0 hydrogen. This place 0 hydrogen is there. So here is the CH3, friend. This is CH3, and here will be the I. This is our required product. Okay, double bond will convert into. Here is again they have given the Finkelstein reaction. So here is the iodide exchange will be takes place, student. So CH3, CH2, and here is I plus, dear student, this is the NaBr. Friend, here next one you see, this will give the addition reaction. So sunlight is there. Oh, sunlight, it cannot give the addition, student. Sunlight is there na, UV light, so it will give substitution reaction. Where it will give substitution reaction, not the double bond, student. Double bond means addition, so it will attack here, student, or it can attack on this position. So only one Br2 is there, so the first time, only one time it will go give the reaction, student. Here the 0 will not be the friend, so here will be the friend, this is the Br, here will be double bond plus HBr is again going to be out. So this is now with the again Finkelstein reaction, student. So NaI will be out, student. Here it will give CH3, CH2 and I are there. This is going to form. Next one is, student, 37. This is what the reaction is called, student. This reaction is called that is short reaction, friend. So how the product it is going to give, student? CH3, 2 molecule CH3, this is the CH2 and what is, student? F plus what is there, student? Hg2Br2 will form. So this is the short reaction. If you are talking about SbF3, take the 3 molecule, student. So it will give 3 molecule of the CH3, CH2 and what is, student? CH3, CH2 and F, this is there, and plus what is there, student? SbBr3, this is there. So this is what the 38. Now let us see the next one, student. What is the question here? 39 one. This is the NaI is there and Cl. So this is what Finkelstein reaction again. So CH3, CH2, this is CH2 and I plus NaCl, student. This is what, right? Next one is L-ethanol, alcoholic KOH is there. So elimination reaction it will give, student. CH3, here will be C, student, again CH3 and double bond, it is the CH2, friend. This is okay. So this is the plus KBr, here is H2O plus KBr. This is next one is, student, next one. Here if you are NaOH there no, and here is Br, so it will give the SN reaction, student, SN reaction. So it will give the SN1, okay. So here it will be the product will be CH3, CH, here is what, student? That will be the OH. This is what, friend? That is CH2 and CH3. This is plus NaBr. This is what the answer. Next one, again ethanol KCN here is there, student. So it is going to be SN2 reaction, student, SN2. So here is CH3, CH2 and here will be Cn, student, plus KBr, okay. Next one is here is, student, this is called the Woods reaction, student. Not Woods reaction, not actually the sodium ethoxide is there, student. So this is not a Woods reaction, this is also kind of the SN2 reaction, student. So what is the NaCl will be out? So C6H5O C2H5. So this is called ester, student. This is the ester plus NaCl is the out, student. This is here you see SOCl2 is there, student. CH3, CH2, CH2 and here is Cl plus SO2 plus HCl, okay. Now here double bond is there, student, peroxide. So which rule we are going to be, student? Anti-Marconi-Cops rule, student, because peroxide is there na. So anti-Marconi-Cops rule we will follow, student, anti-Marconi-Cops rule. So here what will be there, student? Negative part will go on that double bonded carbon which have more hydrogen. So 2 hydrogen and 1 hydrogen. So like that. So here you see, student, product CH3, this is the CH2, again it is the CH2, student. Next one CH2 and here is the Br, student. So 1 bromobutane this will be. Now let us see, here it will be the Marconi-Cops rules, student. Marconi-Cops, because there is no peroxide, Marconi-Cops rule, friend. So here you see this is the negative and this is positive. With this one, if you see, 0 hydrogen are there, 0 hydrogen and 1 hydrogen, okay, 1 hydrogen. So Marconi-Cops rule say that is the negative part go on that carbon which have less hydrogen. So how the product is going to be formed? This is CH3, CH. Here will be the right student. Here is the CH2 because the hydrogen is going to be at this place. Then here is the CH. Here is the Br student. One CH3 here, another CH3 is here. So this is very simple. Next one student, Rx is there NaOH student. This is the SN2 reaction, SN reaction. Okay, we don't know R is what is the degree. So ROH alcohol will form student and NaX is going to be out. Now let us move on the next one, 48. Here will be water is also good nucleophile student. So it will give ROH, that is also SN reaction student, plus HX student. So very simple here. If you are talking about NaOR friend, so you see NaX will be out. So ROR plus it will be NaX student. So this is what the ether student. This is called ether. Next one student, here is the last one we are picking now. This is again Finkelstein reaction student. So R here is called I plus NaX student. So this is how the chemical reaction we are going. In the next series of the chemical reaction, tomorrow we will take the 100 question and 100 reaction of the same chapter student, and we'll try to find out the answers. So this is all about the answers. Thank you very much for watching. If you find any difficulties student, you can ping me, you can comment. Okay, thank you students.